the power of a power. It just means when you have an exponent that's on top of an exponent. So let's just say it was like x to the second power to the third power. Please understand, this is different. That's why I'm writing an equal sign with a line through it. That means not equal to. This is not the same as like x squared times x to the third. What you're gonna be learning today is this right here. You saw this one a little differently. Let me first point out some of the visuals. Notice how in this one, there's only one x, right? Here, technically you had two x's. But here you have only one x. And that one x has two exponents. So whenever you have one base that has two exponents, right? You're not going to add the exponents. You're going to multiply the exponents. Here, you're actually going to be doing 2 times 3. So one of my students told me this a while ago, and I liked it. So I'm actually going to erase this. He was saying how, like, if you just draw a line that connects the 2 and the 3, it's a straight line, and therefore you know it's a plus sign. And 2 plus 3 is 5. Here, when you draw a line to connect 2 and 3 on a diagonal, so that would help you understand that you're multiplying, and you're doing 2 times 3. That's a little bit of a visual. If you like it, use it. If you don't like it, don't worry about it. But once again, to solve this problem right here, you're doing 2 times 3, which is x to the 6th power. Notice how you get two different answers. That's why they're not equal to each other. In short, when one base has two exponents, you're going to multiply those two exponents. That's pretty much what we're learning today. When you raise a power to the power, keep the base and multiply the exponents, right? Just as before, you keep the base alone, but this time you're going to multiply the exponents. Not add them, not subtract them, but multiply them. So I'll write this. This is technically 3 to the 4th power to the 2nd power. Now, the way that my one student explained it doesn't really work here because they wrote it on the same level. That's why I don't really like it, but usually it is off a little bit higher. But once again, go with what I said instead. I have one base and I have two exponents. Whenever you have one base and two exponents, you're going to multiply the exponents instead. So it's going to be 3, right? I leave my base alone. And then it's going to be 4 times 2, which is 8. So it's going to be 3 to the 8th power. Done. I'm not doing anything else with this. Okay, letter B. Once again, one base. I know you technically see two numbers, but 2 sevens is really just one number. So it's one base that has two exponents. So you're going to multiply the exponents. First, you leave the base alone. That means you're going to leave the 2 sevenths alone in the parentheses. And then you're going to do 6 times 4, which is 24. 2a is my base. And that one base has two exponents. So I'm going to leave 2a alone. And I'm going to, in parentheses, and I'm going to multiply the exponents. And 5 times 3 is 15. Last one, I have the one base, which is negative x, in parentheses, of course. And then I have the two exponents. One base, two exponents means I'm going to multiply, and 4 times 3 is 12. Please don't forget though, because this is an even exponent, the negative gets canceled out. So my answer is really just x to the 12th power. Now, I explained to you how to do this, but I didn't really explain to you why. So I want to quickly just go over the why now. Why do you multiply the exponents instead of adding them or subtracting them? X squared to the 3rd power. Well, think about it. My base here is technically x squared. And how many x squares do I have? Oh, you have 3 of them. So you have x squared once, x squared twice, and x squared 3 times. And then here, right, because you're multiplying the same base, technically you add the exponents. And 2 plus 2 is 4, plus 2 is 6. Instead of teaching students how to go from here to here, and then to here, which would be a lot longer, we just tell students, well, if you only have one base, technically multiply the exponents. And 2 times 3 is 6. And notice how I get the answer right away. Try these 4 on your own. And once again, look back. There's a reason why we're doing these notes, right? Look back. How did Mr. Deacon solve this one? Rewatch the video again if you have to. Remember, you can pause me, you can rewind me, you can fast forward me a little bit if you understand it. So none of these really came out perfect. It's because of the exponents on the computer. So we'll just rewrite it again. You have a bracket, parentheses, -4 squared times, parentheses, times -4 cubed, bracket 6. Please understand that brackets and parentheses are the same. Technically, I could erase this. You don't, but technically I could. And I can put parentheses here. The only thing is, you can see how that's confusing, because then you don't know which set of parentheses goes with the other set of parentheses, right? It gets kind of confusing. So instead of doing parentheses on top of a parentheses, we just do brackets instead. All right, so let's go ahead and solve this. Here you have a lot of operations, right? You have the exponents outside, you have the exponents that are inside. Like, what do you do? So you just got to go back to PEMDAS, right? When there's a lot of operations in there and you don't know where to start, always go to PEMDAS. PEMDAS helps you always. So the P in PEMDAS is parentheses. So we're going to do what's inside the parentheses. Once again, even though they're called brackets, they're technically like parentheses. So we're going to do what's inside the parentheses first. So don't worry about that 6, right? Let's just focus on this. -4 squared times -4 to the 3rd power. Well, you're multiplying the same bases. So whenever you multiply the same bases, technically you add the exponents. So it's -4 inside the parentheses, right? And then 2 plus 3 is 5. And then I'll bring down the brackets, and I'll bring down that 6. So that's step number 1. We did inside the brackets, we're done. Step number 2 now is do the outside. We went over this before. If you have one base and 2 exponents, you multiply. So it's going to be -4 inside the parentheses, and 5 times 6 is 30. Now you did all that work, and I hate to say this, but if you stop here, you're wrong. So you got to know when to stop and when not to. That 30 is an even exponent. That means that negative is going to cancel out. So my final answer is actually 4, not negative, but 4 to the 30th power. Right? Once again, an even exponent means that the negatives cancel out. So this one's going to be easier for me to explain. Just there's one little trick. Notice how the m inside the parentheses does not have an exponent. You have to give it an exponent first. We'll give it that 1. Now the rest is going to be easy. You do what's inside the parentheses first, and because you're multiplying the same bases, technically you add the exponents, and it becomes m to the 6th power. But then we also have the 3 exponent outside. From there, we have one base and 2 exponents, so it ends up being m, and 6 times 3 is 18. My final answer is m to the 18th power. So 5 plus 1 is 6, times the 3 is 18. All right, letter C, it's kind of like the last lesson that we did. Let's just focus on the top first. All right, don't worry about the bottom right now. So you're doing what's inside the parentheses first. And because you're multiplying the same bases, technically we add the exponents, and that's going to be 7. 4 plus 3 is 7. Then you're going to multiply it to the 4 to get 28. So it'd be 6 to the 28th power. I literally did the same work that I did here. So on the top is 6 to the 28th power, you're done. Now let's focus on the bottom. Inside the parentheses is just one number, right? It's just the 6. So you're not looking to like add exponents or anything like that. Just basically have a problem that has one base and 2 exponents. When you have one base and 2 exponents, you multiply the exponents. So it'd be 6 to the 10th power. It's 6 to the 28th power divided by 6 to the 10th power. Whenever you're dividing the same bases, you subtract the exponents. All we got to do here now is first keep the base alone. So we're going to leave it at 6. And 28 minus 10 is 18. Last example, this one's going to be a tough one. Once again, here's my division symbol. Anything before the division symbol goes on top. Anything afterwards goes on the bottom. So it's a to the 4th times a squared to the 4th. And then it's 2a to the 8th. Don't get overwhelmed. Do it step by step. First, let's focus on the numerator. You're multiplying the same bases. Therefore, you add the exponents. And 4 plus 2 is 6. Then you have an exponent on top of an exponent, so you're going to multiply. And 6 times 4 is 24. So you're going to get a, right? Leave your base alone, a to the 24th power. Now on the bottom, you can't do anything with it actually. So it's just 2a to the 8th. Now you might think you're done, but you're not. In both problems here, they both have an A on top, A on bottom. So you got to focus on that. And the operation between the two A's is division. So whenever you divide the same bases, technically you subtract the exponents. So it's going to be A, and 24 minus 8 is 16. This is the part that's going to confuse a lot of you. So call me over if you don't get this. Understand that the A to the 16th power is on top because 24 has more players than 8. So the 16 is on top. So here's my fraction bar, and the A to the 16th is on top. But this lovely 2 here, this 2 that a lot of kids tend to forget about, visually, is it on top or on bottom? I hope you sit on the bottom, because it is. So that 2 still remains on the bottom. So my final answer is A to the 16th power over 2. Go ahead and do these on your own and call me over. I feel like for the most part, you can see these numbers well. Don't forget to put a 1 here. The only one that I think might be hard for you to see is number 8. So I'm going to rewrite it real fast for you now. Number 8 is x to the 8th power times x to the 4th, close parentheses, to the 2nd, over x to the 3rd and to the 6th.